Welcome. This is Mr. Anderson, and I want to go over homework 4.5, solving quadratic equations. I'm just going to go over the first 6 problems here to get you started. If you're fast forwarding through this video, you want to just kind of take a look at what problem number I'm on here. So this first problem, it says solve the equation by factoring. Okay, well, hopefully you're comfortable factoring these type of quadratics by now. We know that this is a difference of squares, and this factors to x minus 10, x plus 10. And so I need to solve this. What we are doing to solve this is I want to know what values of x make this equation true. What values of x? This side of the equation is 0. What also makes this side of the equation 0? What values of x make this side of the equation 0? Well, we take a look at this. So I got a binomial factor times another binomial factor. Well, if this binomial factor was 0, if I plugged in some value of x and it made this binomial factor equal to 0, that would be 0 times, I really don't care what this is, because 0 times anything would make this whole side of the equation equal to 0, which would equal this, 0 over here. All right, and the same thing over here. Find out what value of x makes this binomial factor 0, and you'd have 0 times whatever this is, make this whole side equal to 0, make the equation true. All right, so what makes this binomial equal to 0? I'm looking for what makes x minus 10 equal to 0. We'll just solve for x. That's easy enough. Add 10, add 10. X would have to equal 10. And that makes sense. If I plug in 10 for x, that'd be 10 minus 10. That's 0. So that makes this binomial 0. I'd multiply by this. If I plugged in a 10 here, that'd be 20 over here. It'd be 0 times 20 equals 0 equals 0, right? 0 times 20, this side of the equation would be 0. Okay, and same thing over here. I want to find out what makes x plus 10 equal to 0. Subtract 10, and x would need to equal negative 10. That makes sense. If I plugged in negative 10 for x, that'd be negative 10 plus 10. That would make this 0. That'd make this negative 20 over here. It'd be 0 times negative 20, which equals 0. This side of the equation would be 0, which equals this side of the equation, makes this equation true. So these are my two solutions. These two values of x make this side of the equation 0, which makes this equation true. Those are the answers I want to plug in. And it doesn't matter which one you enter first. Negative 10, comma 10. You could plug in 10 comma negative 10. Just make sure and put a comma between them. Good job. Okay, problem number 2. Same type of deal here. I want to factor this and then find out what makes those factors 0. Okay, well, this is an easy one to factor because there is no number in front of the p squared. There's an understood 1. So I know that these first 2 terms are just plain p. And then the next 2 terms in each of these binomials, they have to multiply up to be 42, and they have to add up to be 13. All right, well, let's see. 6 times 7 is 42. 6 plus 7 is 13. So 7 and 6. Okay, let's take a look real quick. Why is that so? Why? Because some students get mixed around. They say, what multiplies up to be 13 adds up to be 42? No, it's the other way around. Multiplies up to be 42, this last term, and adds up to be the middle term. All right, because when we FOIL, if I was to take these two factors and FOIL them back together, the f of FOIL, p times p, gives us this first term here. P times p is p squared, and that's the only way that we get the p squared. Right? The O and the I of FOIL, outside and the inner terms, those add together to give us the middle term here, O and I of FOIL. So that p times 6 is 6p, and 7 times p is 7p. 7 plus 6 gives us the 13. And the only way that we get this number without any letters in it is to multiply two just plain old numbers together without any letters. As 7 times 6 is 42. That's the L of FOIL. All right, the only way we get this last number is by multiplying the last two terms. All right, so the 7 times the 6 equals the 42, and then the 7p plus the 6p equals the 13. All right, enough about that. I want to take a look at what makes these two factors 0. Well, if this was a negative 7, if it was the opposite of this, it'd make this binomial factor 0. So that'd be negative 7 plus 7. P equals negative 7. All right, and same thing over here. If I plugged in the opposite of this in for p, that would make this binomial 0. So p would equal negative 6. So either one of these makes this side of the equation 0. That'd be negative 6 plus 6. That'd be 0 times whatever this is. This whole side of the equation would equal 0. Negative 7 plus 7. This binomial would be 0. It'd be 0 times whatever this is. This whole side would be 0. It would make the equation true. Our two solutions are negative 6 and negative 7. And again, doesn't matter which order I put them in to my answer block. So negative 6, comma, negative 7. All right, good job. Question number 3. Okay, same deal. Let's factor this. Again, no lead coefficient, or the lead coefficient is 1. Understood 1. All right, so that's going to make the first term in each of these binomials just w. What multiplies up to be 100 adds up to be negative 20. That would be negative 10 and negative 10. Negative 10 times negative 10 is positive 100. Negative 10 plus negative 10 is negative 20. All right, so what makes this binomial factor 0? Well, w would have to equal 10, because 10 minus 10 is 0. What makes this binomial factor 0? 10 also. All right, so, and it makes sense, these are both the same. All right, I'm not going to plug 10 in twice. You don't write in 10 comma 10. You just plug in 110. There's only one solution here. Okay, so 10. All right, nice work. Problem 4, solve the equation by factoring. Okay, so the first thing, when you inspect a quadratic, check for anything that you can factor out. All right, look for numbers or letters that the two terms or three terms, however many terms you have, check if they have anything in common. Here they have an x in common, and you're looking for numbers or letters. This has an x in common, so I can factor that out. What I'm left with, take an x out of x squared, I'm left with just x. Take an x out of negative 12x, I'm left with just negative 12. All right, and that's distributing in reverse when you factor out. So you can always distribute back and see if you did it right. X times x is x squared. X times negative 12 is negative 12x. I got it right. So now I want to take a look, what makes each one of these factors 0? Well, if x was 0, that would make that factor 0. It'd be 0 times whatever this is, and this side would be 0. All right, what makes this factor 0? X would have to be the opposite of this. X would have to equal 12, because 12 minus 12 is 0. All right, those are my two solutions, 0 and 12. Let's plug those in. 0, comma 12. Well done. Problem number 5. Okay, so notice here that there's not a 0 on one side of the equation, so what I want you to do is make a 0. Right, make it 0. Get everything onto one side of the equation. So I'm going to subtract off this 18x from both sides of the equation. 18x. And that's going to give me 3x squared minus 18x equals 0. Now it looks a lot like the previous problem number 4. I want to factor out. I want to look, okay, do these terms have anything in common? Yes, they have a 3 in common, and they also have an x in common. So let's factor the 3x out. When I factor 3x out of 3x squared, I'm left with just x. When I factor 3x out of 18x, I'm left with 6. You can distribute it, make sure you did it right. 3x times x is 3x squared. 3x times negative 6 is negative 18x. And then check to see what makes these factors 0. All right. If x was 0, that would make this factor 0. That would be 3 times 0 times whatever this is. But you're multiplying by a 0. So it makes this whole side equal to 0. What makes this binomial 0? If x was equal to 6. That would be 6 minus 6. That would make this 0. It would be 0 times 6 times 3. Well, the whole thing would be 0 because I'm multiplying by 0. Okay, so there's my two solutions, 0 and 6. Let's plug those in. 0, comma 6. Fantastic. All right, and the last question we're going to look over. Okay, so this one says solve the equation by graphing. First, I want to solve this by algebraically. And then Monday we'll take a look at how we solve this by graphing, using our graphing calculator. All right, so first thing again, what I want you to do is get everything on one side of the equation and leave a 0 on the other side of the equation. So subtract this 1, subtract this 1 here, and I'm left with 0 equals 6x squared plus 5x minus 1. All right, so this lead coefficient is not 1, which typically makes it a harder type quadratic trinomial to solve. But I want to use a trick here that will help us solve this more quickly. All right, and here's the trick. Take this lead coefficient and multiply it by the last number. So that gives me x squared plus 5x minus 6. Now I want you to just factor it like normal. Now there's no number here. So now just factor it like normal. Multiplies up to be negative 6 and adds up to be 5. Well, that would be x plus 6, x minus 1. 6 times negative 1 is negative 6. 6 plus a negative 1 would be positive 5. All right, now the next step is to divide each one of these numbers by this lead coefficient. Okay, so x plus 6 over 6 dividing by this lead coefficient here, and x minus 1 over 6. Okay, so the next step is, if you can simplify the fraction, simplify it. Well, 6 divided by 6, that's just 1. So I have x plus 1 here. And I can't simplify this, so this is x minus 1 over 6. And the last step is, if you have a number underneath, here it's just an integer, so just leave it alone. But if you have a number underneath, take that number and plug it right back in front of the x. And you have x plus 1 and, whoops, and 6x minus 1. I just took that 6 and I moved it. All right, so what I'm claiming is that these two binomials, when I FOIL these back together, they equal this. Let's just double check that real quick. Alright, so I got x plus 1 times 6x minus 1. Let's do the f of FOIL. That x times 6x makes 6x squared. Let's do the O and the I of FOIL. The O of FOIL would be x times negative 1. That would give me, whoops, now I gotta start over. Okay, x plus 1 times 6x minus 1. Okay, so the f of FOIL. X times 6x, that's 6x squared. The O of FOIL, that x times negative 1 would be negative x. I of FOIL, 1 times 6x, that's positive 6x, and 1 times negative 1 is negative 1. Combine like terms, that's 6x squared plus 5x minus 1. Good. That works out. Alright, so I was just showing that this method is working out here. Alright, so this equals 0. This is the same as that. And so last thing I want to do, I want to check what makes these factors equal to 0. Well, this one's easy. If this x was negative 1, then that would make this factor 0. How about this one here? Not so obvious. So what we want to do is just, I want to say, okay, well, what makes 6x minus 1 equal to 0? Well, let's solve for x and c. Add 1, add 1. So 6x equals 1. Divide by 6, divide by 6. Well, if x equaled 1 over 6. Alright, so my two solutions are negative 1 and positive 1/6. Negative 1 and positive 1/6. Alright, always check the parentheses underneath your answer though. They want us to round to 2 decimal places as needed. So 1 divided by 6, 1 divided by 6 is 0.1666666 repeating. So my answers here are negative 1, and they want a decimal for this one, because actually we'll be doing this with a calculator. 0.166, and this is just repeating over and over again. So this would round off to 0.17. So my answers are negative 1, comma, 0.17. All right, let's plug those two answers in. Negative 1, whoops, negative 1, comma, 0.17. Excellent. Okay, that completes this first half of 4.5, and we'll be discussing more on Monday. I just wanted to get you started on this assignment. All right, have a good time. I will see you on Monday.